Welcome, CRCI 2026 attendees and esteemed judges, to this explainer. Today, we're diving into a genuinely game-changing medical innovation that directly tackles a critical, yet really often overlooked, vulnerability in medical training. We're talking about the birth fall protective apparatus. It's a brilliant invention out of Barupa University that is fundamentally transforming obstetric safety and student confidence. So let's get right to it. Okay, let's dive into this. Our roadmap today is simple. We're going to uncover the hidden training fear, break down the apparatus design, review the 120-student trial, reveal the surprising results, and finally, look at the real-world clinical impact. Section 1. The hidden training fear, the anxiety of dropping a newborn. I want to ask you, the judges, to imagine for just a moment the immense pressure inside a delivery room. Picture being an undergraduate nursing student. It's your very first time assisting in a vaginal delivery. The stakes are just incredibly high, the environment is intense, and the window for a supervisor to intervene if something goes wrong, it's incredibly small. So what do you think scares these trainees the absolute most? It's the crippling anxiety of making an inadvertent mistake that harms the most vulnerable patient in the room. Well, when the research team polled 200 nursing students at their institution, they uncovered a pretty startling reality. Over 80% of them admitted to being completely terrified of dropping a newborn when assisting with a delivery for the first time. This isn't just your standard pre-test jitters, This is a profound fear that actually impedes their ability to learn. And honestly, this fear is completely justified by the physical realities of childbirth. During the second stage of labor, there's a very real risk of accidental newborn falls. Why? Because you're dealing with rapid infant expulsion, the unavoidable reality of slippery gloves, and a glaring lack of protective equipment designed specifically for the infant on traditional delivery beds. Because the attending supervisor is intensely focused on the mother's vitals and the immediate mechanics of the delivery, the trainees are essentially functioning as the only safety net. Section 2. Designing the safety apparatus, a 3-part blueprint for confidence. To solve this massive problem, the Thai research team engineered the birth fall protective apparatus. Basically, it's a mechanical, add-on safety intervention. Their core design philosophy was safety first, and it was heavily influenced by actual learner feedback and expert clinical comments. They designed it specifically to give students a physical fail-safe without getting in the way of the natural mechanics of birth. It doesn't replace the standard bed. It brilliantly augments it. Let's walk through the blueprint. The whole thing consists of 3 specific parts you can easily assemble by hand. Step 1 is securing the rectangular baby tray. And what's really clever here is that it features a drainage port connected to a hose underneath, which helps monitor and accurately measure postpartum hemorrhage. Step 2 is attaching the supporting tray using a secure half-frame lock. And step 3? You just mount the entire structure onto a mobile 4-wheel drive-in base. It's sturdy, functional, and designed to catch exactly what human hands might miss. Section 3. Testing with 120 students. The randomized controlled trial. Now, to prove this prototype actually worked, the researchers didn't just ask for opinions. They ran a rigorous, randomized controlled trial with 120 undergraduate nursing students. The methodology was beautifully clean. The intervention group used the standard simulation bed equipped with the new birth ball protective apparatus. They were tested directly against the conventional group, who used only the standard simulation bed with 0 additional safety equipment. And they definitely did not make this simulation easy on the students. They were thrown into a 7-minute simulated vaginal delivery scenario. And yes, the researchers actually used a 2,800-gram baby mannequin that they literally sprayed with a mixture of shampoo and water. I love this detail because it perfectly replicates a terrifyingly slippery reality, perfectly mimicking the high-stakes, low-friction environment of actual childbirth. Section 4. Surprising trial results. The proof in the data. We're at the climax of the pitch now, getting into these statistically significant, contest-winning findings of the trial. Now, what's really interesting about this is the massive spike we see in educational self-efficacy. The intervention group scored a 16.03, compared to the conventional group's 13.75. When these students knew that physical safety net was actually there, their belief in their own capability to assist in the birth just skyrocketed. And let's just take a second to look at the statistical weight of that difference. A t-value of 7.33 with a p-value of less than 0.01. In research terms, that is a massive validation. It's not some marginal improvement, it's a night and day difference in confidence. It decisively proves that providing a mechanical safety net doesn't make students lazy, it makes them feel fundamentally more capable in their training. But it gets better. Did feeling safer actually translate into better physical skills? Well, the researchers had 3 senior nurses from outside hospitals evaluate the students' clinical performance from a concealed room. The results? The intervention group visibly outperformed the conventional group, scoring 2.44 to 2.08, proving that peace of mind literally translates to steadier hands. And this brilliantly illustrates the core thesis of this research. With a t-value of 4.69, we see a direct, undeniable link between providing safety tools and improving practical competence. When you remove that crippling cognitive load of constantly worrying about dropping the baby, students actually execute their clinical skills much more effectively. Section 5. Real-world clinical impact beyond the simulation. So the crucial point is understanding exactly how these numbers translate to the human impact of healthcare training. The post-trial outcomes really speak for themselves. First, there was a massive reduction in overall stress recorded on a standard 1 to 10 visual analog scale. With a t-value of negative 9.99, their stress basically plummeted. Furthermore, the intervention group showed significantly higher satisfaction in clinical reasoning and clinical learning. They specifically reported that the simulation helped them recognize their clinical strengths, and crucially, it helped them recognize patient deterioration much earlier. The statistics are incredibly powerful, for sure. But this quote from the study really grounds all those numbers in real emotion. They praised the researchers who built this safety invention because it helped them relieve their stress in training. These trainees felt deep gratitude. They noted that this terrifying problem, the very real fear of dropping a newborn, had been neglected by medical education for way too long. Beyond just the clinical data, let's look at the logistics that make this so viable for rapid global adoption. The manufacturing cost is remarkably accessible, sitting right between $500 and $800. It has a lifespan of over 10 years, it's highly mobile, and perhaps most importantly for rural or underfunded clinics, it requires absolutely zero electricity. It's cost-effective, practical, and completely ready for the real world. As we wrap up this explainer for the CRCI 2026 judges, I want to leave you with one final provocative question. We've seen the data, we've seen the massive stress reduction, and the improved clinical performance. So, how many future birth injuries could be prevented if this Thai innovation became the global standard for obstetric training? Thank you so much for exploring this brilliant breakthrough with me.